We did, excuse me, the first section and the second section look at arithmetic sequence and series. So the sequence again is just the pattern values. The series comes as you're looking at the sums. All right? So we're going to look today at geometric. So geometric works like this. What's the next number in line here? 64. And 128. Okay. So a geometric series, or sequence, geometric sequence works as you go from one number to the next, you multiply by a common number. In this case, we call it a common ratio. So the ratio can be found by taking any term and dividing it by the term that comes before it. So if I take the fifth term and I divide it by the fourth term, I get the common ratio. If I take the eighth term and divide it by the seventh term, I get the common ratio. Okay? So far, so good? All right. To find any term in a geometric sequence, I use this. T to the n equals t to the 1 times r to the n minus 1. T to the 1 in this case is 2. My common ratio in this case is also 2. And then to get any term. So if I asked you what the 15th term was, I go t to the 15 equals 2 times 2 to the 14, which is whatever 2 to the 15th is in this case. That only works because I got 2 times 2. So far, so good? It's not, this again, this is the easy part when we're working through this. All right? Let's look at an example in our book. Andrew and David organize a tree planting challenge. They have people that plant a tree and then sign up 3 more people to join the challenge. Andrew and David are the first to join the challenge, each planting 1 tree and each signing up 3 more people. Okay, so state the values for T1, R, and so on. Okay, so T1, how many people are planting the tree initially? 2. T to the 2, how many people are planting the tree now if each one signs up 3?
6. Wouldn't it be 8 because you still count Andrew David or Andrew David done?
They each sign up 3 people, so that'd be 6 that they sign up plus themselves, which is 2, right?
So 8 total? Okay, well, let's try it. So if that's 8, okay. Now how many do I have? Ridiculous?
32, because there'd be 24 plus their 8.
Couldn't see that?
Okay, wait, he said 8 times 3 plus 8, that?
Yeah.
Okay, yeah, that makes
Okay. So what would the next one be then?
128.
Okay. How many of us are confused by that? A little bit?
I just keep so wait. It started with 2 people and
Okay,
then
so let's do this.
yeah, good.
Let's make it make sense. Andrew and David start here.
Yeah.
Okay? Good?
Yeah.
And he signs up 3 people.
Okay.
And he signs up 3
just
people.
3. They
Yeah.
3 more
So
to
J, K, L, M, and O. So this is my second level right here.
Yeah.
So this is T to the 2. So how many people are in T to the 2?
2 to be 8.
8. So I've got those 8 right there, right? And then I got another 3, another 3, another 3, like this. So that's 24 more on top of the 8.
Yeah. Oh, yeah, that makes sense now.
Okay, good. Good. Just going to erase that. All right. So my T to the 1 value is 2. What was my common ratio?
4.
What was it?
2.
4. Okay. what did I multiply this number by to get to 8? And then what did I multiply 8 by to get to 32? And then 32 to 128? 4. So I can check it multiple times. If I'm not sure, I can check it multiple times. Okay, so I've got that. Now, it says, then state the geometric sequence. Okay, so this is how I start again. Now, we talked about this at great lengths. When I'm doing that, we talked about great lengths when I was doing lines. So now I need a general term. So what are the values I have to replace to get the general statement here? What are the two values that I have to replace to get a general statement? Very good. So my general statement reads this. If I want to find any term, nth term, I start by going T1, which is 2, times 4 to the n minus 1. So if I'm looking for the 15th term, I do that. Okay? So this is the general statement. That's what you're looking for. Now, for whatever reason, 2 or 3 of you in here are going to mess that up somehow. All right? You just have to replace t to the 1 and r when you're writing your general statement. You don't even have to simplify it. The other one, we simplified, remember, the t to the n equals t to the 1 plus n minus 1 times d. We simplified that. You just got to write that right there and you get it right. Okay? So far, so good? So if you filled in your blanks all the way down, you would have t to the n equals 2 times 4. The n minus 1 is your general term of this sequence. All right. Okay. Now, this guy. I'm trying to think. We did this. I don't know if we did this. That's the only problem. I don't think we did it and applied. But let's do this now. Look at example 2. A company stores 5 kg of a radioactive material. After 1 year, 92% of the radioactive material remains. How much radioactive material will be left after 10 years? State your answer to the nearest tenth of a kilogram. Okay, so the first thing I need is t to the 1. What's t to the 1 in this case? 5 kg. What is my r here? 0.92. Because I'm going to have 92% left, right? Yeah? Okay? And then it wants after 10 years, correct? So I go t to the 10 equals 5 times 0.92 to the 9. All right, punch that into your calculator, please. Just so we know how to do it, in case we have calculator errors. What's the answer?
2.36.
3 decimal places?
1.
Perfect. Everybody else? Good? Okay. Good. All right. So far I've kept consistent with the arithmetic sequence as well. We started, first of all, by looking at a pattern, how to find the common difference, and then the general term leading us to find any term, right? So we're now doing the same thing. So the next stage then is what happens if they don't give us, bless you, if they don't give us the T1 or the R. So look at the next one. They give us the 5th term in the sequence is 1,050. So T to the 5 is 1,050. The 7th term is 26,250. Okay, I'm gonna show you two methods again. The one that's consistent, the method that's consistent with the arithmetic one is the first method I'll show you. Okay, so I put the larger term first, 26,250 equals t to the 1 times r, and since it's the seventh term, this is 6. Okay? So that's actually their equation 2 for the record. And then I go 1,050. So this is their equation 1. T to the 1 times r to the 4. Just like that. Okay? You follow so far? Any problems? I just substituted into the term. Is that okay? All right, now, when I did this with arithmetic, I subtracted the two equations. Do you remember that? Subtracting the two equations? But because I'm doing geometric, I'm going to divide the two equations. So I'm going to take 26,250 divided by 1,050. Put that in your calculator, please. Is the answer 25? Yep. Okay. Now I take t to the 1 divided by t to the 1. What do I get? 1. And I take r to the 6 divided by r to the 4th. What do I get? R to the 2. Great work. Great work. Okay? So I've got r squared equals 25. What does r equal? Was it? 5. All right.
Plus or minus 5.
Yeah. Because I'm taking the square root, it can be plus or minus 5. So I go like this. All right? And I'll show you this. That'll make more sense when I show you the other way of doing this question. Okay, so I got plus or minus 5 right here. So now I'm just going to substitute it in to find out what
T1.
T1 is. So that's 5. It doesn't really matter in this case if it's plus or minus because it's an even value, but even exponent. Anyways, so here's what I have here. So take 1,050 and divide it by 5 to the 4th. What do I get?
1.68.
Okay, find out what that is as a fraction, please.
How do you do that?
Yeah, can you do that on your calculator? Or do you have to do that mentally?
No, you should really do it in calculator.
What?
Do you know how to go from percent to decimals and decimals? 1.68.
Take 1,050 and divide it by 5 to the 4th.
Yeah.
I did the other way too, and that's what I got too.
What'd you get?
That, 1.68. I did the
That's what I got too.
262 thinking about that.
I just did one. I just did.
42 over 25. So
Okay.
that was
Oh,
that
that's
FD button. Yeah.
Okay.
But you can leave it like that. I feel like there's something wrong with this.
Shouldn't it equal 5?
Divided by 5. No, 5.
I don't know, I was just looking in the book, so the answer could be really.
No.
Is that the answer in the book?
Yeah,
Okay.
Yeah.
Okay.
so do you don't want to delete that?
No, that's fine. That's all good. 1.68. Okay? Oh, I see that down at the bottom. Now, any questions about how that we did that? Again, this is very similar to what we did with arithmetic, right? Instead of subtracting, we're dividing. Okay, now I'm going to show you a slicker way of doing this.
Not getting it right.
You're using times 10 to the power of 4.
Oh.
Use your hat.
Oh. Just looking at the book, they do it both ways to get the same answer. So just because it's a whole, it doesn't matter if we use a plus or a negative.
No, because I've got an even exponent. And if you, so like 5 squared is 25, negative 5 to the power 2 is also 25.
Yeah.
Okay,
That's
so,
decimal.
yeah.
Do it both ways.
Okay, so here's what I'm going to show you now. This this one only works slick if the two values are given 2 apart. Okay? So t to the 5th is 1,050, right? And this is 26,250. Agreed? So far? All right. Now, my math says that if I take this term and divide it by 1,050, I'm going to get r. Or if I take this term and divide it by x, I'm going to get r. Okay? So watch. If I go with that x over 1,050, and that's equal to 26,250 divided by x. Just like that. Okay? I should end up with the same thing. Now that's because this is 5, this is 6, and this is term 7. Right? I feel like it's not working. What am I doing wrong here? Is that likely too? It should work. Oh yeah, that's right. It's gonna work. Okay, my bad. Sorry guys. So if I cross multiply right now, I get x squared is equal to 1,050 times 26,250. X is equal to. Okay, so take the square root of 1,050 times 26,250, please.
$5,250.
5,250. What I just found was the 6th term, right? So if I take the 6th term and I divide it by the 5th term, I should end up with my r. Five? Yeah. Now this, because again, I was using that, could be that too. So if that's the case, then this makes that plus minus 5. Because I take the square root, it can be a plus or a minus. All right?
So it doesn't work if you go like T5 plus T7 and then
You
divide them
can't
by.
plus because you're doing geometric, which means you're multiplying. There's no plus. Okay? All right? That's it for today. Any questions from yesterday on your sums?
How do we do 4A on page 19?
Okay, so I'm gonna use this as my equation. Right, that's my sum equation. Okay, so it gives me the sum is minus 256. Gives me the term, which is 32. It gives me D, which is 6. You get that far? You did? Okay. What's 32 divided by 2? Okay. I'm going to take minus 256 and divide it by 16. What do you get? So this is what you're left with, Amber. Now what are you going to do? 186.
Negative 202.
Yeah. Now what?
Divide by 2.
You
Does
can.
that work too?
Yes, absolutely. Absolutely, it does. If you times 16, that gives you 32, and then whatever 16 times 186 is, yeah, that's fine. Okay, there's nothing wrong with that. Okay? Any other questions then today? 16 here, 32 divided by 16, and then I divide that 16 to this side. 256 divided by 16 is negative 16. See that or not? Yeah? So I divided this by that. Okay?
On page 10, number 9, I wasn't quite sure how to start that. I'll set it up.
Which one?
Number 10, page 10, number 9.
5 fence posts are equally spaced between 2 corner posts that are 42 meters apart. How far apart are the 5 fence posts?
14 meters apart, but you're talking about in between each fence, right? I didn't know how to set that up.
Alright, you good now?
Sure, yeah.
You can draw, that easiest thing would be to draw your posts and then count how many spaces you have and divide it into 42.
Okay.
Okay?
Thank you.
Okay, you got the rest of this morning to work on 1.3. Make sure that you are on 1.3 already, okay?